I'm going to be presenting about chemistry in The Simpsons. So, for a rough overview of The Simpsons was a cartoon show which is essentially supposed to represent a satire of a normal working class family. So, in this show, we have characters such as the lazy dad and the troublemaker's son. So, in this episode of season 2, titled Bart the Genius, the titular character Bart is supposed to represent the troublemaker's son. So in this episode, Bart swaps IQ papers with a student in school, and for this reason, he scores especially high on an IQ test, thus sending him to a school for the gifted. Essentially, in this clip I'll be showing you, he's in this school for the gifted, and he's mixing together two chemicals to show the reaction I will be explaining now.
Hey, what's that? It looks dangerous.
Well, it's really pretty top secret, ma'am.
All right, keep going. But you do know what happens when you mix acids and bases, right?
Of course I do.
In this scene, Bart attempts to mix together an acid and a base. We are not told whether it is a strong acid or a weak acid or a strong base or a weak base.
Sorry.
Together the acid and the base, the entire thing exploded and created a green goo. So obviously as AP chemistry students, we know that this will not actually happen. But the show writers essentially thought, since the average person thinks acids and bases are super opposing, that when they mix together, the entire thing would explode for comedic effect. So in the real world, when you mix together an acid and a base, a neutralization reaction happens. Essentially, this reaction creates, for a strong acid and a strong base, it creates a salt that is neutral, meaning the pH is 7, and it also creates a water. So as you can see in this example here, we mix hydrochloric acid and sodium hydroxide base, and this creates the salt, NaCl, and the water. So when a strong acid reacts with a strong base, that's when the salt is neutral. In this next reaction, we can see that when a strong acid reacts with a weak base, it creates a resultant salt and again creates the water. So we can see here the hydrogen nitrate and the iron hydroxide, which create the iron nitrate and the water. So the iron nitrate is the one that is acidic. Now, when a strong base reacts with a weak acid, the same thing happens, where the resultant salt is basic in nature. So in this example here, we can see the hydrogen carbonate plus the potassium hydroxide creates the potassium carbonate and water. So in this case, the potassium carbonate is the one that's basic, and it also creates water. So the basic one obviously has pH greater than 7, and the acidic one has a pH less than 7. In this last case, when a weak acid and a weak base react with each other, complete neutralization does not occur, so I don't think we need to take this into account for the show.
In this animation, we will see what happens when a strong acid, HCl, and a strong base, NaOH, combine. So we can see here the Cl and Na ions as well as the H plus ions. So basically what happens is the H plus ions from the strong acid and the hydroxide ions from the strong base can combine to form water in the reaction that you can see on the screen in a couple of seconds. There you go. And then the Na and Cl ions are unaffected, so this will result in NaCl, the salt. In this short clip, we'll see a real-life example of a neutralization reaction. So in this experiment, they are adding lemon juice, which is an acid, and baking soda, which is a base. So we can see the chemical reaction there take place in the bowl. And if we wait a little bit, then we can start to see the salt and the water at the top of the bowl. Another problem with this clip is that it violates the law of conservation of mass, stating that mass should neither be created nor destroyed in a chemical reaction. However, in this clip, as you can see on the left, Bart adds together a small amount of reactant and creates a huge amount of product. A neutralization reaction does not cause any sort of explosion, as you can see in the clip, And also, according to the law of conservation of math, there shouldn't be that amount of product remaining in the clip. So therefore, this scene is incorrect. Thank you.